Hi, so let's go through question 10 from the mixed exercise. A few people saying they were having some difficulty with that. Start by stating the conditions. I'll just talk you through them. The four things you need to know in order to be able to assume a random variable has a binomial distribution are a fixed number of trials, only two outcomes, success or failure. You need to have a constant probability of success, and all the trials need to be independent. Four things, 2 marks. Good. Okay, the second part. There's actually essentially two separate but linked questions, and it brings us to a different calculation this time. It asks us to do something different, so I'll go through this one quite slowly. To begin with, we have to find the probability that he has 2 successes out of the first 10 houses. So I'm going to start by writing out what my distribution is. Well, x can be the random variable, which is the number of successes he has, and x can be modelled as a binomial where there are 10 trials and our probability of success is 0.05. We want to find the probability that he has at least 2 successes, so we want the probability that x is greater than or equal to 2. We have to convert that into something with less thans because our calculator and the tables only do strictly less thans. So this is equal to 1 minus the probability that x is less than or equal to 1. I can get that value up on the calculator very easily, and that is 0.9139. Okay, which means that the value we're actually after is 0.0861 to 3 significant figures anyway. Okay, all good. Let's clear that one and look at the second. So our second question, part C here, or possibly our third question, presents us with a quite different question. In this case, we're asked to find the smallest number of houses so that he can get a success of at least 0.99. So in this case, let's say that y is our random variable. So this is the number of houses he's successful with if he canvasses n. So y can be modelled as a binomial with n trials and a probability of success of 0.05. Now we're trying to find the probability that y is greater than or equal to 1. Again, we can't do greater thans, so this is actually just quite simply the probability that x doesn't equal 0. Or to put that another way, it's 1 minus the probability that x equals 0. So that is equal to, sorry, let me just pause a second. We're trying to actually say that this probability here has to be more than 0.99. So let's rewrite that now. That is 1 minus the probability that x equals 0 has to be more than 0.99. Okay, move the page up. I know how to do that. There we go. So rearranging this gives me the probability that x equals 0 has to be smaller than 0.01. Okay, now the probability that x equals 0 is something that we can work out based on our knowledge of the binomial distribution. It's the probability of failure for every single test. So that's 0.95 to the power of n, and that has to be smaller than 0.01. Okay, you'll notice the sign changes. You need to be careful with your sign changes here. If you need to go through the steps more carefully to rearrange from here to here, do so, but make sure you understand why the sign has changed. Okay, this is a question right now. Sorry, pausing again. This question here is something that we can solve using logarithms. So I'm going to take logs of both sides. That gives me log of 0.95 to the n must be more than log of 0.01, remembering that log in this case means log base 10. Could use any base that I liked. I could have used log of 0.95, but that would present a specific problem which you should ask me about, or ask Mr. Ryan about, when we're doing logarithms revision. Oh, all right then, I'll tell you. If you take a log which is below 1 in an inequality, it's like timesing by a negative, and so the sign will change. Okay, right. So we've hit this point here. We're going to rearrange, so we get n log 0.95 is less than log of 0.01. Obviously, we need to divide by log of 0.95. So n is related to log of 0.01 over log of 0.95. Right, as I just spoke to you about earlier, dividing by a log, or taking a log which is below 1, is like dealing with a negative number, because log of 0.95 is a negative number, so the sign changes again. Be very careful with the signs in these. So now n is just a number which we need to calculate. N has to be greater than 89.78. Therefore, our n value is 90. I hope that helps you, and I hope that clears up any misunderstandings. Do ask about anything you haven't understood, or just go back through it, but come back to me with anything that's proving difficult.